Hi everyone, and welcome to our video on looking at functions that are increasing and decreasing and their relative maximums and minimums. So an increasing function, let's get that increasing, it's bolded there. Increasing function, our kind of quickest way to say it is if we're looking at a graph, it goes up from left to right. So something like this, like that, something that goes up from left to right. So as x increases, y also increases. So that's what it is, going up to left to right. Decreasing is x increases, y decreases. So from left to right, the graph goes downhill or downward. So something like that. And then we can say, well, if I'm drawing these segments that are looking like lines, then we can say, oh, they have slopes. Graph has the positive slope for when it's increasing. Graph has a negative slope for when it's decreasing. Then we have things called turning points. So these are the x values. So the x values at turning points are called critical values. So something like this right here is where I've got a turning point. Okay, so whatever that x value is called a critical value. And then the y value at that turning point is called a relative extrema. Okay, so whatever that point is, so that x is called the critical value. And then that y would be called the relative extrema. Okay, and I'm abbreviating relative. They might also call it local. Local extrema. Okay, so there's some information. Now, some of this might look familiar from some algebra things, but let's break down this graph and find all of this information. So it says the graph of f of x is given, and sometimes they'll mark it like this to the side, like y equals f of x is given. Find the following, list the following, the critical values. Okay, so the critical values are the x values at turning points. So we have a turning point right here and a turning point right here. So the critical values then are those x values, -2 and 2. That's it. Okay, so just making sure we got our definitions down. Okay, relative minima. Okay, so when we said extrema, so the extrema is either a minimum or a maxima. And minimum or maximum, they just use different vocabulary again to mean the same things. But a relative minima would occur when I have a turning point that's low. A relative maxima would occur when I have a turning point that's high. Okay, so our relative minima looks like it is that 7 right there. Okay, because that's the lower turning point. So we've got 7. And we just say it just like that. The relative maxima is where I've got my higher turning point. That looks like that's the 39. So we've got, let's even label it on here. So we'll abbreviate relative max. The 7 is the relative minimum. Okay, so we've got 39. And they call them relative. So notice it's not like the smallest y coordinate. Notice there's a much smaller -42 down there. The reason they call them relatives, relative maximums or relative extremas, is because they use this vocabulary saying that we've got a neighborhood, a small neighborhood around this point. And in this small little neighborhood, that 39 is the biggest value. And similar over here, if I draw a little circle around it, we would say, oh, in this neighborhood of the graph, just like a neighborhood in a town or a city, in that small little region, that is the smallest y value. Okay, so let's see these others. The relative minimum points. So now they just want the actual point, 2, 7. There's only one on this graph. So it depends on the graph. Maybe you have something like this, and that has lots of relative maximums and minimums. Okay, but this one, there's only one. And then relative maximum points, well, we already see that too. There's only one, the -2 and 39. Okay, so there's all that vocabulary. Let's scroll just a little bit. There's a little more. Then it also asks the intervals where f of x is increasing. Okay, so where f of x is increasing, again, that's where it's going up from left to right. So I'm going to start marking this in blue. So it's where I draw it upward from left to right. So I'm starting here, left to right. Looks like I'm going up, 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 up until I hit the turning point. Okay, so this in the blue is where it goes increasing. And then it is decreasing until I'm here, and then let's draw that right there also. Okay, so this in the blue is where it's increasing. Increasing and decreasing intervals always get parentheses. So it is an interval. So let's mark that also, always parentheses. Okay, so at this, even though it's a solid dot here on the left where it starts, we would say it starts at -5 with a parenthesis. Okay, so I'm just marking it there. And then it stops at -2. So the x values is what we're concerned with, stops there. And I'm just marking it along the graph right below. But for our interval, we would say -5 with parenthesis to -2 with a parenthesis. And then we see, oh, it does it again at 2, and then it stops at x equals 3. So we usually use our union symbol, and then we'll do 2, 3. Okay, so that's where it's increasing. Now let's see where it's decreasing. Again, it's intervals. All right, so we can see it's decreasing here in the purple where it's drawing downward. Okay, so that's where I draw downward from left to right. And it starts at -2 and it goes to +2. And then that's it. So -2 to +2. Okay, and then that's our final answer there. Okay, so a lot of new vocabulary, or if you're took the algebra, a lot of similar vocabulary there. Use those colors if they help. Otherwise, thanks for watching, and I'll see you again next time.